Hello, well, here we are. Not in class, but we can still do some things. I've got a few things I'd like you to do. Go ahead and go to Canvas, and you're going to go to the Files section, go to Quizzes. You're going to find Quiz 6. This is the quiz I had prepared for you to do today, or, yeah, whenever it is you're watching this, Monday. And you'll notice I call it a group quiz. I was going to have you do it in groups just to give you a little bit more confidence. But go ahead and download this and give it a try. Just do these first two problems. You can watch the video and we'll do the rest of it together. So take a minute and go ahead and download this. I'm going to go ahead and put this in Notability, and then I will do it. So pause the video, try this yourself, and then come on back. All right, well, welcome back. Let's go ahead and do this. This first problem is pretty straightforward. The only difference between what you did in Calc 1 and this is this I and the j, those placeholders to sort of indicate the vector function, the fact that x equals t squared minus 4 and y equals t cubed minus 5t. So derivative is easy. You're just going to do r prime is going to be 2t times I, and then 3t squared minus 5 times j. And then the second derivative, also pretty straightforward, 6t times j. Now we're supposed to compute the everything, I guess, r of 1, r prime of 1, and so on. So r of 1, I'm just using this original function up there. It's going to be negative 3i minus 4j. So plug 1 into that, you'll get this, negative 3. So that's the point. I guess I could write it like this. So it looks like a point, but it's also a vector. It's this point down here. That's this point, negative 3, negative 4. I could draw the vector, but it's not really necessary. Next, we're going to compute r prime of 1, and here we will draw the vector. So this is going to be 2i minus 2j. So I'm just using this r prime to get that. So over 2 and down 2. So let's see if I can draw that. I guess I shouldn't have put this right there. Maybe I'll put it right there. Okay, so to the right 2, down 2, it's going to be something like this. But the important thing is that, okay, so this is the vector over 2, down 2, is that it points in the same direction as the curve. So that's kind of cool. And then finally, we'll do the second derivative. That's going to be 2i plus 6j. So over 2 and up 6. So let's see, it's going to go over. I suppose I should have marked this down, or marked labeled the axes. So I think I did a pretty good job there. This will be 4, so this is negative 3, negative 2, negative 1. This is negative 4. So something like this. The only reason I'm marking this down is to better draw this vector. So this particular vector over 2 and up 6. And so we're going to start here at negative 3, negative 4. And we're going to go over 2 and up 6. And we're going to end right about there. So let's see. So there it is. So that's r double prime of 1, which is over 2 and up 6. And in the context of motion, the r prime, that 2, negative 2, is, of course, going in the direction that you're moving. And the r double prime is the direction of the change of motion. So it's the acceleration. And you're always going to be accelerating towards the center of well, maybe not towards the center, but towards the inside of a curve. As you're going around a curve, the acceleration always goes inward. All right, let's try this next one. So hopefully you can figure out what's happening here. is essentially you've got a derivative of a function, and you're supposed to come up with the function itself. You probably are familiar with this from Calc 1, having an initial condition. Sometimes we call this a differential equation. It's not much of one. We're just going to do an integral. But notice that we have three separate integrals that we're going to have to do. And those three separate integrals are going to each have their own constant of integration. And so the way that I'm going to do this is I'll do something like this. R of t is going to be the integral of r prime of t. Yeah, that's not entirely correct, but I'm going to let it slide for now, because it's easier to just think of it this way. And so in this case, I'm just going to do the antiderivative of each of these functions. So here you have a t squared minus 3t. So you're familiar with antiderivatives. And then plus the constant of integration. So that's the deal here, is that we're going to have a bunch of constants of integration, one for each of these components. The antiderivative of sine is the negative cosine. So this will be negative cosine of t plus a second constant of integration. So I know it feels a little bit weird that you're going to have three separate constants of integration, but that's the way that this works out. Really, it's one constant of integration, but it's a vector. And so we're just separating this into the three components. So I just find this to be easier. And then finally, the antiderivative of cosine is sine. And so you have sine of t plus c3. So now this separates this into three separate problems, so you don't have to think about these all together. It says r of 0 is 1, 2, 3. So let's write down, what is r of 0? Well, plug 0 into this, and you just get c1 times I. Let's see, 0. Cosine of 0 is 1. So this will be negative 1 plus c2 times j. And then sine of 0 is 0, so that'll be c3 times k. I guess this was kind of extra. All right, so that means that this c1 has to equal 1 for this to be true. Negative 1 plus c2 better equal 2 for that to be true, which means c2 has to equal 3. And then c3 has to equal 3. So my final answer is that r of t is equal to t squared minus 3t plus 1, there, times I, plus, let's write the 3 first. So I'm just going to insert these 3 into the previous answer there. And then, whoops, plus sine of t plus 3 times k. So there you have it. All right, what we're going to do is we'll be doing this next, but I don't want to make this video too long. So I'm going to pause this video, and then we'll start up a new one for the second part of today's lesson.